When dealing with a gas manifold system in a high-rise condo, especially when servicing 89 units, proper bonding of the gas stubs is crucial. It is generally recommended to bond all gas stubs at the manifold regardless of any assumed continuity provided by a unistrut rack or similar support structure. There are several reasons for this recommendation. Firstly, electrical safety. Bonding helps ensure that all gas piping components are at the same electrical potential. This significantly reduces the risk of electrical shock or sparking, which could occur if a difference in potential exists between different parts of the gas system. Secondly, code compliance. Most electrical codes and gas safety standards explicitly require the bonding of all gas piping components, including stubs. These codes are in place to protect both the occupants of the building and the integrity of the gas system itself. Ignoring these requirements could result in violations and potential safety hazards. Thirdly, potential for corrosion. If the gas pipe is not properly bonded, there is a potential for different electrical potentials to develop between the stubs and the main gas line. This can lead to galvanic corrosion, which is an electrochemical process that can degrade the piping over time, potentially leading to leaks or failures. Fourthly, reliability. Bonding provides a reliable electrical pathway between all components of the gas system. This ensures proper operation of the system and minimizes the risk of electrical interference or stray currents affecting the gas flow or control mechanisms. Addressing the gas company's recommendation, while they may advise against bonding the main gas line itself, it is still crucial to adhere to code requirements and safety standards by bonding all individual gas stubs. Relying solely on the unistrut rack for continuity is not a reliable or acceptable substitute for direct bonding. The unistrut rack may not provide a consistent and low-resistance electrical path between all the stubs, and its effectiveness can be compromised by corrosion, loose connections, or other factors. Bonding only the first stub and assuming continuity through the rack does not meet the required level of grounding and protection. Therefore, to ensure electrical safety, code compliance, and the overall reliability of the gas system, it is advisable to bond every gas stub at the manifold. This involves using appropriate bonding jumpers, which are typically copper wires of a suitable gauge, and ensuring proper electrical connections to a common bonding point. The common bonding point should be connected to the building's grounding system, providing a direct path to earth for any stray electrical currents. The specific size of the bonding jumpers and the method of connection should comply with the applicable electrical codes and gas safety standards. Typically, bonding conductors are sized according to the size of the largest ungrounded conductor feeding the equipment the gas line is serving. It is crucial to consult with a qualified electrician or gas system professional to determine the appropriate bonding methods and materials for the specific installation. They can assess the existing electrical system, gas piping configuration, and local code requirements to ensure that the bonding is performed correctly and effectively. Proper bonding involves several key steps. Firstly, identify the common bonding point. This is the central location where all the bonding jumpers will be connected. It should be a low impedance connection to the building's grounding electrode system. Secondly, prepare the gas stubs. Clean the surface of each gas stub where the bonding jumper will be attached. Remove any paint, corrosion, or other contaminants that could interfere with the electrical connection. Thirdly, attach the bonding jumpers. Use appropriate connectors, such as bonding clamps or lugs, to securely attach the bonding jumpers to the gas stubs. Ensure that the connections are tight and corrosion resistant. Fourthly, connect the bonding jumpers to the common bonding point. Route the bonding jumpers from each gas stub to the common bonding point and securely connect them. Again, use appropriate connectors and ensure tight, corrosion-resistant connections. Fifthly, inspect the connections. Thoroughly inspect all bonding connections to ensure that they are properly installed and secure. Use a multimeter to verify the continuity of the bonding system and confirm that there is a low resistance path between all gas stubs and the common bonding point. Sixthly, document the bonding. Keep a record of the bonding work, including the size and type of bonding jumpers used, the location of the common bonding point, and the results of the continuity tests. This documentation can be helpful for future inspections and maintenance. In addition to bonding the gas stubs, it is also important to ensure that the gas meters themselves are properly bonded. The gas meters are often equipped with bonding terminals specifically for this purpose. Connect a bonding jumper from the meter's bonding terminal to the common bonding point or to a nearby grounded metal surface. This helps to prevent electrical potential differences between the meter and the gas piping system. When selecting bonding materials, it is important to choose materials that are compatible with the gas piping and the surrounding environment. Copper bonding jumpers are commonly used, but they should be protected from corrosion if they are exposed to moisture or corrosive substances. Stainless steel bonding jumpers may be a better option in certain environments. The size of the bonding jumper should be appropriate for the expected fault current. The National Electrical Code, or NEC, provides guidelines for sizing bonding conductors. Consult the NEC to determine the appropriate size of bonding jumpers for the specific gas piping system. The NEC Table 250.102 C1 can be used for sizing the bonding jumper. It's also essential to ensure that the bonding connections are accessible for inspection and maintenance. Avoid burying or concealing the connections in walls or ceilings. If the connections must be located in a concealed area, provide an access panel or other means of accessing them for inspection. Regular inspections of the bonding system are recommended to ensure that the connections remain tight and corrosion-free. During these inspections, check for any signs of damage or deterioration to the bonding jumpers or connectors. If any problems are found, repair or replace the affected components immediately. It is also important to educate building occupants about the importance of the gas bonding system and to discourage them from tampering with or disconnecting any of the bonding connections. Post warning signs near the gas meters and piping to alert occupants to the presence of the bonding system and to instruct them not to interfere with it. In summary, when dealing with the gas manifold system in a high-rise condo, bonding all gas stubs is a critical safety measure. It helps to prevent electrical shock, reduce the risk of corrosion, and ensure the reliable operation of the gas system. Do not rely solely on the unistrut rack for continuity. Instead, bond each gas stub individually using appropriate bonding jumpers and connectors. Consult with a qualified electrician or gas system professional to ensure that the bonding is performed correctly and in accordance with all applicable codes and standards. Furthermore, grounding and bonding are critical electrical safety concepts aimed at minimizing electrical shock hazards and ensuring the safe operation of electrical systems and equipment. Grounding provides a low impedance path for fault currents to flow back to the source, while bonding connects conductive parts to create an electrically continuous path. Effective grounding and bonding practices are essential in various settings, including residential, commercial, and industrial environments. The grounding system consists of a grounding electrode, which is typically a metal rod or plate buried in the earth, and a grounding conductor, which connects the electrode to the electrical system. The purpose of the grounding electrode is to provide a reference point for the electrical system and to dissipate fault currents into the earth. The grounding conductor must be sized appropriately to handle the maximum expected fault current. Bonding involves connecting all non-current carrying metal parts of an electrical system, such as enclosures, raceways, and equipment frames, to create an electrically continuous path. This ensures that if a fault occurs, the fault current will flow back to the source through the bonding conductors, tripping the circuit breaker or fuse and energizing the circuit. Bonding conductors must also be sized appropriately to handle the expected fault current. There are several types of grounding and bonding systems, including the grounded system, the ungrounded system, and the impedance grounded system. The grounded system is the most common type of system in which one of the conductors, typically the neutral conductor, is intentionally grounded. The ungrounded system does not have any intentional connection to ground, while the impedance grounded system uses an impedance such as a resistor to limit the ground fault current. The choice of grounding and bonding system depends on the specific application and the desired level of safety and reliability. Proper grounding and bonding practices are essential for preventing electrical shock hazards. If a fault occurs in an electrical system, such as a wire coming loose and contacting a metal enclosure, the enclosure can become energized, creating a shock hazard. Grounding and bonding provide a low impedance path for the fault current to flow back to the source, tripping the circuit breaker or fuse and de-energizing the circuit before a person can come into contact with the energized enclosure. In addition to preventing electrical shock hazards, grounding and bonding also help to reduce the risk of fire. Fault currents can generate heat, which can ignite flammable materials. Grounding and bonding provide a path for the fault current to flow back to the source, tripping the circuit breaker or fuse and preventing the fault current from overheating the wiring. Furthermore, grounding and bonding also help to protect sensitive electronic equipment from damage caused by voltage surges and transients. Voltage surges can occur due to lightning strikes, switching operations, or other disturbances on the electrical system. Grounding and bonding provide a path for the surge current to flow to ground, diverting it away from sensitive equipment and preventing damage. The NEC contains detailed requirements for grounding and bonding electrical systems. It is important to follow these requirements carefully to ensure the safety and reliability of the electrical system. The NEC specifies the size and type of grounding and bonding conductors, the methods for connecting grounding and bonding conductors, and the requirements for grounding electrodes. In addition to the NEC, there may be local codes and regulations that also apply to grounding and bonding electrical systems. It is important to check with the local authorities to determine the specific requirements for the area. Grounding and bonding should be performed by qualified electricians who have the knowledge and experience to perform the work safely and effectively. The electricians should be familiar with the NEC and local codes and regulations. They should also use appropriate tools and equipment and follow proper safety procedures. Regular inspections of grounding and bonding systems are essential to ensure that they are functioning properly. Inspections should be performed by qualified electricians who can identify and correct any problems. Inspection should include visual inspections of grounding and bonding connections, as well as electrical tests to verify the continuity and impedance of the grounding and bonding system. Grounding and bonding are critical electrical safety concepts that are essential for protecting people and property from electrical hazards. Proper grounding and bonding practices can prevent electrical shock, reduce the risk of fire, and protect sensitive electronic equipment from damage. It is important to follow the NEC and local codes and regulations carefully and to have grounding and bonding work performed by qualified electricians. Remember that ensuring a safe environment requires continuous attention to detail and adherence to established electrical codes and safety standards. Understanding these concepts and applying them diligently is essential for anyone involved in electrical work or responsible for the safety of electrical systems.